Hi everyone, welcome to this class on carbon and its compounds. So good evening everyone, and we are going to be revising this carbon and its compounds with some very important questions, and I'm going to make the concepts really easy for you. So hope all of you are doing great, and I'm sure all of you are working hard and preparing for your exams. So be sure to watch this entire class, and I'm going to make the some concepts super easy for you. So let's go ahead and begin. And before I start, I just want to say that do check out the courses on our website, because I have some really exciting news for you. We have launched new courses in physics, chemistry, maths. So we have new courses for ICSE class 10 and also for CBSE class 8. So I'm super excited to announce that, guys. We have launched these new courses for ICSE class 10 today and also for CBSE class 8 this week. So guys, do check out the courses on our website. We have physics, chemistry, maths for CBSE and ICSE class 9 and 10 and for CBSE class 8. And we also have a Java coding course. So do check it out and share it with your friends, because I take more live classes on our website. We have interactive videos. There are mock tests for you to practice before your exams, and we discuss the solutions also for the mock test, and there are quizzes and questions, and you can ask doubts. And the best part, we have some awesome discounts going on. So guys, do check out the links. I've put the links below, and do share it out with your friends. And if you haven't subscribed to our YouTube channel, please hit the subscribe button right now, and also do share our channel with your friends. Hi everyone. It's great to see a lot of people here, and please hit the like button for this class, and we are going to be doing this very important revision on the carbon and its compounds chapter. So I'm going to be going through some very important questions on this chapter, and it will be a great revision for all of you. So keep your pen and paper ready, and let's start. And do check out the new courses on our website, as I told you, and please do share it out with your friends. The website is manochaacademy.com. I put the links below. Awesome, guys. All right, guys, so let's go ahead and start. Here's our first question. What type of bonds does carbon usually form? So is the answer electrovalent bond, ionic bond, hydrogen bond, or covalent bond? What do you guys think? So come on, guys, I want all of you to try here. So what type of bonds does carbon usually form? Electrovalent, ionic, hydrogen bond, or covalent? Very good. I can see a lot of answers here, and awesome. I think everyone's writing the correct answer. Carbon usually forms covalent bonds. Excellent. So what is the difference? Because you know that ionic or electrovalent, these type of bonds are the same thing. And when does this occur? When there is a transfer of electrons. And what do you have in covalent bond, guys? In covalent bond, there is a sharing of electrons, right? When atoms share electrons so that they can reach their stable state, the octet state, right? And why does carbon have covalent bonds? Because, guys, you know, carbon's atomic number is 6, right? The mass number is 12. So what is the electron configuration of carbon? It's 2, 4, right? 6 electrons, 2, 4. So how will carbon achieve its stable state, the octet state? What does it need to do, right? So it has the option of, you know, either losing 4 electrons, right, to get to the duplet state, or gaining 4 electrons, right? And then it will become 2, 8. But it doesn't do any of that. Why? Because for it to lose 4 electrons, it would require a lot of energy to remove 4 electrons, right? So that is very difficult to remove 4 electrons from carbon. And if you add 4 electrons, then total electrons will become 10. So it's very difficult for the 6 protons to hold on to the 10 electrons. So that's why carbon does not prefer transfer of electrons. Losing or gaining, it does not like. It's a nice friend. It likes to share its electrons. Okay. And sharing of electrons, you know, it forms covalent bond because it shares electrons with other atoms so that it can fill up this second shell, right? So it will share 4 electrons, and that will make it 8. So this will turn it into 2, 8. So, and guys, you know, sharing of electrons is covalent bond. You know, sharing is caring and carbon is a caring guy. He forms covalent bonds. Awesome. Let's go on to our next question. How many electrons are shared in a carbon-carbon triple covalent bond? So what do you guys think? So come on, I want all of you to participate, and awesome to see 200 likes. Guys, if you haven't hit the like button, please hit it right now, and let's try this question. So when you have a carbon-carbon triple bond, right? So let's say you have two carbon atoms and they have a triple bond between them. How many electrons are involved here? So guys, we are looking at a triple covalent bond. Like nitrogen forms a triple covalent bond between, right? So another example is nitrogen. Similarly, carbon can form a triple covalent bond. So how many electrons? Some of you are writing 2, some of you are writing 3, some of you are writing 6. This is a tricky question because one very important thing for you to remember is one covalent bond, right? Or each covalent bond has how many electrons? 2 electrons, one from carbon, one from the other carbon, right? So each covalent bond equals 2 electrons. And how many bonds are there? 3, because it is a triple covalent bond. So total how many electrons will there be? So total electrons will be 3 multiplied by 2, right? Excellent, because it's a triple covalent bond. Awesome. So I see a lot of you are writing 6 now. Fantastic. That's the right answer. 3 times 2, 6 electrons. So the correct answer will be 6 electrons, right? Because each bond is 2 electrons. So how does it look like? So if you draw the carbon atoms, right, you have to replace each dash, each of these covalent bonds with 2 electrons. So in reality, the triple bond looks something like this, and then of course, you know, you have the 4th electron also of carbon. Okay, so is that clear, guys? So please take a look here. In reality, the triple covalent bond is basically sharing 3 pairs of electrons because each covalent bond is 1 pair. Please remember that. Each covalent bond is 1 pair of electrons. So 3 times 2, the answer is 6. Awesome. All right, next question, guys. So this question is for all the football or soccer lovers, right? Which allotrope of carbon has carbon atoms arranged in the shape of a football? So here you can see the picture of a football here. So what do you think is the answer here? Which allotrope of carbon? And you know carbon has many allotropes like diamond, graphite, right? There are many allotropes of carbon. So what will be the correct answer here? Okay, which are arranged in the shape of a football. So very good. I see some of you are writing fullerene, but better to write the full name. Do you guys remember the full name? Actually, you know, I forget the spelling of it. So please write it carefully. So you guys know that carbon atoms are on all these points, right? So if you consider the football shape, on all these edges and all these places, you have the carbon atoms, right? These are all carbon atoms. And what is the correct answer? Fantastic. I can see a lot of you are writing it. Superb. So the correct answer is Buckminster fullerene. Okay. It's a long name. Buckminster fullerene is absolutely the correct answer, right? And you know that, or it's often known as the buckyball shape, right? And you know that this is C60. Very good. Some of you are writing C60. Because in this football shape, this allotrope of carbon, one molecule has 60 carbon atoms. There are 60 carbon atoms here. Excellent, guys. So what is the atomicity of carbon in this case? And please note the spelling carefully. Buckminster, not minister. Okay. So, you know, sometimes we misspell it as minister. It's Buckminster fullerene. And what is the atomicity of carbon here? The atomicity of carbon will be 60, right? Because one molecule is having 60 carbon atoms. Fantastic. I see Samyak has the correct answer. Very good. Chandan Kumar Mandal, excellent. Ayush Pandey has also written 60. Absolutely the correct answer. Badrish, very good. All right. Next question. Identify the functional group of the following compound. Butanone. Okay, guys, do you know how to sketch out these compounds to draw the structural formula? So think about that, or even if you don't want to think about the structural formula, what is the functional group here? So functional group, you know, is a very important group which defines the chemical properties of the compound. So what is the answer here? Is it ketone, alcohol, carboxylic acid, or aldehyde? What do you guys think is the answer here? Come on, I want all of you to participate, and please hit the like button if you haven't hit it already. Okay, so butanone, guys, you know how it looks like. You have all these carbon atoms. Okay, and then of course you'll have all the hydrogens, and then there will be a double bond here, right? A carbon in the middle will have a double bond, and of course you can fill in all the hydrogens here. So the remaining will be hydrogens. And remember to draw only 4 bonds, right, from each carbon atom, because the valency is 4. So this is butanone, and you guys are absolutely right. The functional group is ketone. Where is the functional group here? Here you can see the ketone, right? What is important about the ketone? Carbon and double bond with oxygen, and then 1 carbon on each side. Okay, so you guys have a carbon on each side. You cannot have a hydrogen. So please note, in ketone there is C double bond O and 1 carbon on each side. Excellent, fantastic, you guys rock. A lot of you have written the correct answer is ketone, and you can identify from the name because it ends with that "one," right? Can you see? Ketone, butanone. So you guys are right. Next question. Carbon has millions of compounds, you know. Carbon is the topper in the number of compounds an element has. It has millions and millions of compounds. Name the 2 properties of carbon responsible for this. This is a very famous question. And when they ask you specifically, name 2 properties, you need to be a science student. You need to write what are the 2 properties here that causes, so you have to name the 2 properties that causes carbon to have millions and millions of compounds. So come on. Very good. I see Arshi Mistry has written tetravalency. Fantastic. Even Ridhima, excellent. And Anushka Yadav is also written here. Awesome, guys. So one answer is tetravalency, right? What do we mean by that? I'm going to explain you. So one property is tetravalency. What is the second property? Catenation. Awesome. You guys rock. Fantastic. Catenation. So what is the meaning of these 2 properties? Very, very important. The 2 properties of carbon that cause it to have millions and millions of compounds. Tetravalency is very simple. It means carbon has valency equal to 4. Now, why is that important? Because carbon does not have a small valency like 1 or 2. Its combining capacity is relatively high, right? It has a valency of 4, which means it can combine with 4 other elements which have valency 1, or maybe 2 other elements which have valency 2, right? So it can have 4 bonds. Very good. Okay. So it can have valency of 4, which basically means 4 bonds. And just like I told you guys earlier, make sure for each carbon atom you are having 4 bonds. You're drawing 4 bonds because valency is 4. That means it can combine with more elements, so there will be more combinations. Okay, so more number of compounds. And why? What is the meaning of catenation, the second property? So very important, you guys should know these terms. Catenation means the ability to form chains, right? The ability to form chains, and it forms chains with itself. Catenation, right? Carbon forms chains with itself, right? So for example, you guys know that the carbon chains are quite long, and it's important that they are stable, because if the compound breaks down, it's unstable, then it's not important, right? Very good. Or we say self-linking. Ananya Basak has written self-linking, right? So this self-linking property, catenation property, right? So that is the meaning of catenation, that carbon forms bonds with itself and it ends up forming these long chains, right? So it is forming bonds not only with other elements, which is the valency, it is also forming these bonds with itself and it forms these long chains. Now the chains can be very long, they can be cyclic, different types of chains, and so therefore again the number of combinations can be very, very high, which means it will have millions and millions of compounds. Awesome. So these are the two most important properties. Very good. I think Fact Files has written isomerism also, but here we are looking for the two key properties, right, which is tetravalency and catenation. Yes, isomerism also, because with the same molecular formula it can form different structures. Okay, excellent. But these are the two most important, tetravalency and catenation. Please remember this very famous question. Awesome. Let's go on to our next question, guys. Identify the given compound. So you can see there's a compound near my head, right? And you need to name this compound. Is it hexene, benzene, cyclohexene, or cyclohexane? What do you guys think it is? And if you guys haven't hit the like button, please hit the like button right now and make sure you have hit the subscribe button for our channel, because we I take live classes here, we put videos on our channel, so make sure you do that. And guys, also do check out our website for more courses. We have full courses for class 8, 9 and 10. We've just launched the class 10 ICSE course and the class 8 CBSE course. So guys, do check it out. The links are given below. So what is the answer here? Some of you are writing benzene, some of you are writing hexene. What do you think is the answer here? So how to analyze this? If you take a look at this compound, what type of bonds do you see here? Do you see any double bonds here? Are there any double bond, triple bond, or are there only single bonds? What do you guys see? Right? So you guys can see in this compound, we can see that there are only single bonds. Please note, the compound has only single bonds, because these bonds with hydrogen are single, right? So if I remove this hydrogen, I can write it like this also, right? So every carbon is having two hydrogens, okay? So I'm just going to erase that. So and also you can see the bonds between carbon are all single bonds, right? So when you're looking for the bonds, you're only looking for the bonds between the carbon atoms, because is it single, double or triple, right? Actually the bonds with hydrogen are single bonds, but we don't care about that. So we are looking at the bonds between the carbon atoms. So only single bonds between carbon atoms, right? As you can see here, 1, 2, 3, 4, 5, right? Okay, 1, 2, 3, 4, 5, 6. 6 single bonds here. So definitely it is not an alkene, because there are no double bonds. So this ene fellows are out. Hexene is not the answer. Benzene cannot be the answer. Cyclohexene cannot be the answer, right? So what is the correct answer here? Because clearly it has only single bonds, and how many carbon atoms are there? 1, 2, 3, 4, 5, 6. So clearly it is a hexane, because it's an alkane, right? Excellent. So the answer will be hexane. But this is something special here, right? Because it is a cyclic compound, right? Can you see it is a cyclic, forms a cyclic chain. So the correct answer is cyclohexane. Okay, that's the full answer, cyclohexane. So the answer will be D. And please remember, it's not cyclohexane, right? It's cyclic. Okay, not cyclohexane. Cyclohexane is the correct answer here. Awesome. Next question. Alkenes are saturated hydrocarbons, unsaturated, cyclic hydrocarbons, or none of these? What do you guys think? So which one fits this category the best? Alkenes. Saturated, unsaturated, cyclic hydrocarbons, or none of these? What do you guys think here? So what is the difference between saturated and unsaturated hydrocarbons? Okay, so what is the difference here? So one simple way to remember is saturated means only single bonds between the carbon atoms. So that means you can have only this kind of single bonds between carbon atoms. So saturated means all of the bonds have been filled up by other elements, right? Like hydrogen or somebody else, right? Unsaturated, on the other hand, means double or triple bond. So you know carbon can form single covalent bond, double covalent or triple covalent. So double or triple bonds between the carbon atoms, right? So unsaturated means it will be like this, right? There will be a double bond between carbon atoms, or there can be triple bond, right? And why they called unsaturated? Because this double or triple bond can easily be broken, right? You can think it can be broken like a Kit Kat chocolate, you know, because I like to use the example of Kit Kat here. You can see the double bond looks like a Kit Kat chocolate, right? So you can easily break the double bond or the triple bond and add more elements, right? So unsaturated means it is not completely filled. Saturated means all the bonds are filled. Okay. So what do you think is the answer here? Alkenes. So alkene means, the word ene means it is a double bond, right? You guys know this. Alkanes are the single bonds. Everybody knows this, right? Alkane means single bonds. Alkenes means the hydrocarbons which have double bonds, and alkynes are the hydrocarbons with triple bonds. These are all hydrocarbons. What is the meaning of hydrocarbon? They only have carbon and hydrogen in it, right? The only two elements, carbon and hydrogen. So what will be the answer here, guys? Alkene means clearly double bond, right? And we know that double bond means it is unsaturated, because the saturated are the alkanes. Why saturated? Because all the single bonds are there between carbon atoms and rest is occupied by other elements. So the correct answer here for alkenes is going to be unsaturated hydrocarbon, and that is why it can easily do addition reaction, right? Saturated hydrocarbons means only substitution reaction, but unsaturated hydrocarbon, the bond breaks easily like a Kit Kat and you can have addition reactions. Awesome. Next question. Which is the simplest alkyne? This is a very interesting question. Is it methine, ethine, propyne, or 1-ethine? What do you guys think will be the answer here? Wow, we are almost close to 400 likes. Thanks a lot, guys. And please hit the like button if you haven't done it. And let's try this next interesting question. Which is the simplest alkyne? So alkyne, please remember, it means triple bond, right? Because we just discussed alkane is single bonds between carbon atoms, alkene is double bond, alkyne is triple bond. So what do you guys think here? Wow, awesome to see 408 likes. Thanks a lot. So please try this next question. What is the correct answer here? Some of you are saying A, some of you are saying B, okay, some of you are even saying C. So what do you think is the answer here? So how do you work it out? So these questions you don't have to learn much, right? Just think here. Let me show you a simple technique. Alkyne means triple bond, right? So definitely for a triple bond, please remember the triple bond is between carbon atoms. So when we say single bond, double bond, triple bond in organic chemistry, in carbon, right? We talk about, because carbon is the king here, right? So when we are saying single, double, triple bond, it means between two carbon atoms, not other atoms, right? So if you have a triple bond, you must have at least two carbon atoms. Yes or no? Because you want a triple bond between the carbon atoms, and carbon is not forming triple with something else, right? So this is what we need. And then obviously the remaining will be hydrogen, because each carbon must have 4 bonds for tetravalency. 1, 2, 3, 4. This carbon also 1, 2, 3, 4. So clearly I've drawn here the simplest alkyne for you. It has 2 carbon atoms, 1 and 2, right? With a triple bond, and the rest is hydrogen here. So what is the correct answer here? Fantastic. The simplest alkyne is not methine, because meth means only 1. Eth means 2. You guys know the IUPAC nomenclature, right? So if you break this down, if you write ethyne, eth basically means 2 carbons, right? And the ine part means triple bond. So clearly the correct answer is simplest alkyne is ethyne. It is not methine. You can have methane, but you cannot have methine because you need at least 2 carbon atoms. Is that right? We need at least 2 carbon atoms here, so it cannot be methine, guys. Fantastic. And why 1 ethine is not correct? Because you don't need to write 1, right? It's like writing 1 water or something, right? So it doesn't make sense here to write 1. Even though it's not wrong, we don't write 1 ethine. So that's not a good option. And propyne means 3 carbon, prop. So meth is 1, eth is 2, prop is 3, bute is 4, right? Pent is 5 and so on. Why not methine? Because methine means only 1 carbon. And how will you have a triple bond between if you have only 1 carbon? Because you need 2 carbon atoms for triple bond, right? Is that clear? Only methane you can have. But that is an alkane, right? Here we are asking about alkyne. So this one is methane. But this we are not interested in because this is an alkane. We want an alkyne here. Awesome. Next question. What is the previous homologue of pentanol? This is a very famous question on homologues, right? So what is the previous homologue? Like for example, you can get the next homologue or the previous of pentanol. So very simple. You guys know the homologous series, right? So things having the similar chemical properties, right? But they basically differ in the carbon and hydrogen atoms. So you add 1 carbon and 2 hydrogen. Okay. So what will be the previous homologue of pentanol? So what series are we talking about here? Because it's all, therefore these are the alcohols, right? So in alcohols, you know what is the first alcohol, right? So in alcohols, you start with 1 carbon atom. So 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon and so on, right? 6 carbon. So pentanol means we are talking about 5 carbon here. Pentanol. So what will be the name of the alcohol which is previous to this? So that means we are interested in 4 carbon alcohol, right? So what will be the correct answer here, guys? Previous one, not the first one. Some of you are writing methanol. No, the correct answer is going to be butanol. Excellent. Because you know 1 carbon means it's called methanol, right? 2 carbon is called ethanol. 3 carbon is prop, right? Remember? Propanol. So 1 is meth, 2 is eth, 3 is prop, 4 is bute, 5 is pentanol, and the next one here, this will be hexanol, 6 carbon alcohol. So since we are asking for the previous, so the correct answer for previous is going to be butanol. Do you guys agree? Is that the correct answer? Excellent, butanol. If they asked you what is the next homologue, then the answer will be hexanol. So previous means 1 carbon less, next means 1 carbon more. Awesome. Now let's move on to our next question, guys. This is very interesting question. There are 3 compounds A, B and C that occur successively on a homologous series. What is the difference in mass of compound A and C? So what is this question saying? You have 3 compounds. Let's say A, B and C. And these are all part of a homologous series. Okay. So they're successive on a homologous series. We don't know which series. It can be alkanes, alkenes, alkynes. Homologous series are so many, right? So what is the difference in mass of compound A and C? So they're basically asking you the mass difference. Mass difference, so basically C minus A. So which basically means mass of C minus mass of A, right? Mass of C minus mass of A. So what do you guys think it's going to be? Very interesting question. So one very important thing for you guys to know in a homologous series, right? Let's take a simple example, okay? Because they have not given us what homologous series, so we can take a simple example. Let's say we are going to take alkanes, okay? Just for an example, because we don't need to know that here, but let's say A is methane, okay? CH4. Then what will B be? So the next homologue, you always need to add CH2 plus CH2. That means one carbon and two hydrogens. So the next homologue will be C2, because one carbon I've added and two hydrogens, so C2H6, right? What will be the next homologue? Again you add one carbon, so C2 plus 1 is C3, and then again you add two hydrogens, so H6 plus 2 will be H8. Do you guys get the idea? And as you can see, this is methane, ethane and propane, right? Now what is the mass difference between C and A here? If you look at this example, so clearly guys, you can see that the difference, right? So the difference between C and A, so difference between C and A, what is it? So clearly you can see the difference between C and A is 2 carbons, right? And 4 hydrogens, right? There are 2 carbons and 4 hydrogens. And so what will be the mass difference? Why? Because every time you go to the next homologue, you add a CH2. But here we have gone to 2 homologues, right? So it's basically the difference between, the difference here is 2 times of CH2, right? Because difference between 2 homologues is 2 successive homologues. A and B is CH2, B and C is CH2. So here it's going to be C2H4. So what will be the answer here? So what will be the difference in mass? Very simple guys. So it's going to be C2H4. So what will be the mass of C2H4? So carbon, you know, mass is 12U. So 2 times 12 plus 4 times 1U. So what is the answer here? This is going to be 24U plus 4U. So I'm getting the answer as 28U. Do you guys get that? The difference is basically 28U. Why? Because CH2 2 times, right? Awesome. CH2 2 times. Why? Because remember this key point, every successive item on the homologous series differs by CH2. 1 carbon, 2 hydrogen. Now in this question we are taking 2, right? We are skipping 1 compound. So we are taking the, not the next and next, right? So it's going to be C2H4. Is that clear guys? Difference between A and B is going to be CH2. How much is CH2 difference? 12 plus 2, 14. So 14U here and again 14U here. So 14U plus 14U, answer is going to be 28U. Clear? Awesome guys. 28U is the correct answer, and thanks a lot. We have more than 500 likes. That's great. Where am I from? I'm from Kolkata in India. So my name is Sandeep Manocha, and guys, if you haven't subscribed to our YouTube channel, make sure you subscribe. And also do check out the new courses on our website. I'm super excited to let you know that we have launched the CBSE Class 8 course, the ICSE Class 10 course. So guys, do let your friends know, your siblings or friends who are in the lower classes. You can let them know about the Class 8 course or the ICSE Class 10 course, and do share it with your friends. All right. Now let's move on to our next question. So this was our previous question where the difference was 28U. U means atomic mass unit. Remember, these are the mass units that you have studied in the previous class. So by U, I mean atomic mass unit. Carbon is basically 12U, right? Carbon is 12U and hydrogen is 1U. So I've used those numbers here. Can you see here? All right. Next question. This is an interesting question on an IUPAC name. What is the IUPAC name of this following compound? What do you guys think? And I want all of you to try here. So when you're looking at the compound, first check that, what type of bonds are there? How many carbon atoms are involved here? Okay. So what is the IUPAC name of this compound? So clearly you guys can see that there is a triple bond here, right? Can you see the triple bond? Okay. And always important to count the number of carbon atoms. And one very important recommendation is please number the carbon atoms forward and backwards. I'll explain you why. So this will be 1, 2, 3, 4, 5, and then number it backwards also 1, 2, 3, 4, 5. So we have found the longest chain. longest continuous chain of carbon atoms. So how many are there? So we have 5 carbon. That means this must be a pent, right? Pent something, okay? And since there is a triple bond, right? So since we have a triple bond, so what type of compound is this? Excellent, guys. Wow, you're already ready with the answer. It is a ine, right? It's an alkyne because of the triple bond. So if we combine these two, pent and alkyne, right? What is the name? It's going to be a pentyne, right? Excellent, guys. So the name of the compound is going to be a pentyne. Now the question is, where is the triple bond present? So if you look at this numbering, the top numbering, it is present between 4 and 5, right? So always when it's present between 4 and 5, we can say it is a 4-pentyne. But if you look at the numbering below, it is present between 1 and 2. Because between 4 and 5, we choose the smallest number. We don't have to say 5-pentyne, we say 4-pentyne, because it's between, the triple bond is between, right, between the 4 and 5. So we can say 4-pentyne, or also another way to write it is pent-4-ine, because we are giving the position of this. But this may not be the correct name, because check the lower numbering. If you check the lower numbering, it's between 1 and 2. So therefore it is a 1-pentyne, the smallest number, 1-pentyne, or simply pent-1-ine, right? So we go for the smallest scheme, but the best part is you don't have to write 1, because 1 is default, right? We don't have to write 1-pentyne. We simply write this answer as pentyne. So you have to analyze it in your mind. You don't have to write all these details. So it is clearly not 4-pentyne, and we don't have to write 1-pentyne or pent-1-ine. This final answer is simply pentyne, because we don't have to write the number 1. Okay. If your school insists on writing 1-pentyne, that's fine, but that is not the convention. Usually you just simply write pentyne. Not that it's wrong. 1-pentyne is also fine, right? So it's basically simply pentyne. How did we get it? Pent is 5 carbon, ine means triple bond. Awesome, guys. So fantastic. I saw many of you got it right. So this is the correct answer, pentyne. Excellent. Next question. What is the IUPAC name of C5H10? This is a very interesting question. They have not given you any structural formula. What is this called? This is called the molecular formula, right? So you can see it's just written C5H10. No structure has been given. Now, what do you think this compound is? So come on, I want all of you to try. What is the IUPAC name of C5H10? So the IUPAC naming scheme, right? You have to use that. So what is this going to be? Okay. So again, here you can see there are 5 carbons. So again, it's going to be a pent, right? But we don't know what is it going to be. Is it an alkane, alkene, or alkyne? So how do we decide that? So there's one very interesting trick. You guys should know that alkanes have the general formula CnH2n plus 2. Do you guys know this? So if there are n number of carbon atoms, hydrogen will be 2n plus 2. Alkenes. So be very careful with the spellings. Alkane is CnH2n. Alkene is 2 hydrogen less. So it's CnH2n. So 2 hydrogen less than alkenes. And alkyne is again 2 hydrogen less than alkenes. So alkynes, the general formula is CnH2n minus 2. So C5H10 fits into which category, guys? So these are the, right? These are the general formulas for alkanes, alkenes and alkynes. So if you see the numbers, N is the, like the X or the variable here. So which one does it fit into? Alkane, alkene or alkyne? What do you guys think? Fantastic. Absolutely right. It fits into alkenes because you can see N and 2N, right? Why? Because 10 is 5 times 2, right? So if you take N as, let me write it this way. If we take N as 5 here, you can see hydrogen is basically, the carbon is 5 here and hydrogen is basically 2N. 2 times 5. So it's clearly an alkene, right? And so what will be the full name? Because it's an alkene, the answer is C5H10. It will be pent, right? Plus an ene. So the final answer is pentene. That is absolutely the correct answer here. Pentene. Okay. Yes, very good. So Amrita is asking, it could be cyclopentane also. Excellent point. But usually we do not assume the name for cyclic compounds. You're absolutely right. This could be, if you draw it out, you know, just like we drew cyclohexane, remember? If you draw it out, even cyclohexane follows the CnH2n, but you could write that as an alternative answer, but usually we are doing the simple thing. We're trying to detect an alkane, alkene or alkyne. So we ignore the cyclic here. Absolutely right. Yes, these general formulas are in syllabus. They're part of the homologous series. So this is absolutely, this general formula is in your syllabus, CnH2n plus 2, CnH2n and CnH2n minus 2. Awesome. Next question. What is the IUPAC name of the following compound? So let's say if you have a compound like this, what will be the name here? Come on, can you guys try this out? So what is going to be the name of this compound? So whenever you are analyzing this, what is the first thing? Please look for the longest continuous carbon chain. Okay. So what is the longest continuous carbon chain? It can be these 3 carbons, or you could consider these 3, right? So if you consider the carbons, right, it can be 1, 2, 3, this one, or 1, 2, 3 here. So clearly the longest chain is a 3 carbon, and since we have a double bond here, we are going to include it in the main chain. So this is going to be 1, 2, 3 here, or backwards 1, 2, 3. Okay. Excellent. So very good. I can already see some of you writing the answers here. So clearly this is a 3 carbon chain, right? And then you can see that there is some attachment here, because if you forget about this attachment, right? So if you just consider CH3, this C and CH2, if you forget about the attachment, we can name this first and then think about this extra attachment which I'm drawing in pink here. Okay. So, and since the double bond is here, the numbering should start from the double bond. So 1, 2, 3 is the correct numbering, the lower one, because we have to use the smallest number. Okay. The double bond, you have 2 options, right? The double bond is between 2 and 3 or between 1 and 2. Double bond gets higher priority than these attachments. So we choose 1 and 2 for the double bond, right? So what is the name of the main chain here? Clearly you can see there is 3 carbon. So it is a prop plus an ene, right? So there is a prop and a double bond. So the main thing is a propene. Awesome. And then what is the attachment here? Clearly you can see the attachment is CH3. So what is the name of CH3, guys? What do you call CH3? 1 carbon and 3 hydrogen, right? It's CH4 minus 1 hydrogen. So it's clearly an alkyl, right? Which means this is a methyl. Fantastic. Some of you are already writing that. So this attachment is basically methyl. So we're going to say methyl propene. But we need to give the position of methyl also, right? So what is the position? Where is methyl located? So how did I get this name? First look here. If you ignore the methyl, so I'm going to erase it again. The main chain has 3 carbons and we included the double bond in the main chain, right? So it is a propene, 3 carbons with a double bond, and then there is a attachment here, CH3, and this attachment is basically your methyl. It's an alkyl, right? Methane minus 1 hydrogen. Now we have to give the position also. The position is, it is at position number 2. 2, and between the number and the letter, you need to add a dash. Don't forget to do that. 2-methyl propene. Very good. Some of you are writing prop 1ene. You're giving the position of the double bond, but that's not needed because 1 is the default position. So this is absolutely the right answer. You can also write 2-methyl prop 1ene, but that's not needed, guys, because 1 is default, right? It's like writing H2O1. We don't need to write that, okay? So definitely this will be the final answer. So we can write it simply as 2-methyl. So this is the recommended answer. So final answer is going to be 2-methyl, because always between the number and a letter, don't forget the dash, 2-methyl propene. So always this attachment in the beginning, it comes in the beginning, right? So attachment like alkyl attachment is written first. So methyl propene, just like my name is Sandeep Manocha. So here propene is like the surname and methyl is like the first name, and we have to give the position. So just like we say Sandeep Manocha, here it is methyl propene and 2-methyl. And these rules we can't change, right? These are IUPAC naming, right? So we are following these rules. Awesome. Let's try another interesting question. What is the IUPAC name again for this compound? So I want all of you to try here. So again, take a look at the carbon chain. What is the longest continuous carbon chain? Clearly you can see it's this one, 1, 2, 3, 4, and then you have 1, 2, 3, 4. So how many carbons do we have in the longest chain? Wow, we have more than 600 likes. Thanks a lot, guys. If you haven't hit the like button, please hit it right now, and do share our channel with your friends. And as I said, do check out the full courses on our website. The links are given below. I take more live classes on our website. We have quizzes, questions, mock tests, and the entire course is covered. So great for your preparation. And the best part, they are available on big discounts. So do take a look. So come on, I want all of you to try the IUPAC name of this compound. So what is it going to be? Okay. So we have marked. So first thing is, look at the longest carbon chain. There are 4 carbons. We are done with that. Look for functional groups. How many functional groups do you guys see here? So can you guys tell me how many functional groups can you see here? Very interesting question. Yes, Banani Malarkar is saying, please teach ICSE board. I'm super excited to announce, that we have launched the ICSE class 10 course as well. So class 9 and 10 course is also available on our website. Class 9 was already there. So we have ICSE and CBSE courses now, and we've also newly launched the CBSE class 8 course. So guys, do check out our website and let's try this question. Okay. So what are the functional groups here? You can see there is a COOH and there is a chlorine here. Please note, this is not carbon. Be very careful, guys. This is not carbon. This is Cl, our friend chlorine here. Okay. So what is COH? Clearly you can see this is the carboxylic acid functional group, right? And this is the halogen or the halides. So we have 2 functional groups in this compound. Very interesting question. So what will be the answer? Come on, I want all of you to try here, guys. Yes, Adarsh Kumar, I want all of you to try. You also try this question. Everybody, guys. So great to see so many people responding here and trying the questions here. So everybody, please take a look. What will be the answer here? So we have 2 of these. Now there is a priority scheme, right? Since you have 2 functional groups, carboxylic acid takes first priority. So this COH group, our carboxylic acid group, it gets higher priority than the chlorine group, which is the halogens. So this is very important. You should know about priority, right? So the naming is based on the carboxylic acid and the halide is the attachment. So why I mean by priority? So the numbering will be done according to carboxylic acid. This one gets higher priority. Okay, very important to know. So what will be the numbering based on? Carboxylic acid tells chlorine, I'm high priority, so I want position number 1, or basically the lower position. It does not always have to be 1, right? So it says that I want the earlier position. So therefore we will not go for this numbering scheme. So I'm going to erase it. The numbering scheme going to be used now is the lower one, because carboxylic acid is at position number 1. Then the chloride will be at position number 3. Okay. So guys, what will be the answer of this? So what is the name going to be then? The full name, if you ignore the chlorine for now, what will be the name of the base thing? If nothing was there, it was a butane, right? Because there are 4 carbons, so it would have been a but, right? So if nothing was there, it would have been simply a butane. But clearly there is a carboxylic acid there, so we remove the E. Remember, we delete the E and we write butanoic acid. That's how the carboxylic acids are named, butanoic acid, right? And we don't have to write 1 butanoic acid because it's already in position 1. So I'm going to ignore 1. Okay. And where is the chloride there? So where is the chlorine? Chlorine is at position 3. So how do we write it? Chlorine name comes earlier. So we write chlorobutanoic acid and we must give its position. So let's write the position. It's going to be 3 dash chlorobutanoic acid. Is that the correct answer, right? Please check, guys. Not 2 chloro. So if you follow the lower numbering scheme, please understand, guys, you cannot choose both the schemes. This is not allowed. So either you have to go for the top numbering 1, 2, 3, 4 or the lower scheme. Why did we choose the lower scheme? Because carboxylic acid says it has higher priority than the halogens. Okay, so I'm going to remove this because it would have become 2-chloro-4-butanoic acid. That's not good because butanoic acid has higher priority. So it's actually 3-chloro-butanoic acid. Is that making sense, guys? Right? So the correct answer is 3-chloro-butanoic acid. Again, why? Because please remember, carboxylic acids, they have higher priority than the halogens, just like aldehydes have higher priority than the halogens. Okay, clear? Excellent. I see that Fazal Rahman has the correct answer, 3-chlorobutanoic acid. And again, please remember, between the number and a letter, a dash. Between 2 letters, you don't have to put a dash. So you can see there's no dash here. And usually IUPAC names are written in small letter. Sometimes, some schools are using capital letter. That's fine. You can also, usually the convention is to write in small letter. Okay. So please make sure this is the correct answer. If you chose the scheme on top, if you wrote like this, then what would have been the answer? It would have been something like 2-chloro-4-butanoic acid, right? 2-chloro-butan-4-oic acid. Right? It would have been this answer, or so basically this answer will be wrong because it will not be in butanoic acid wants position 1, not position 4. It has higher priority. So this is the correct answer. So please remember, guys. All right. So very, very important to keep in mind of the priority between when there are multiple functional groups. So you have to number it appropriately. That's why I always recommend to write the numbering forward and backward as I've done in my videos. So guys, you can check out some more videos I have on the YouTube channel on carbon chapter. So please make sure you watch it. And guys, if you haven't hit the subscribe button for our channel, please hit the subscribe button right now and do share it out with your friends. All right. How do you know? So Vaibhav Gupta is asking, how do you know that carboxylic acid has higher priority? There's a whole priority list with carboxylic acid, aldehydes, alcohols. They are higher priority than the these halogens, and the alkyl group is the lowest priority. So please make sure you guys watch my video. You can search for IUPAC naming nomenclature, right? So you can search for this video. It's called, I think, IUPAC nomenclature, Manocha Academy on YouTube. So if you'd like to know more of these IUPAC naming rules, because they're very important in the syllabus, so you can watch that, and I've given the whole priority list there. Awesome. So you can search for more videos on our channel, and of course we have even more videos on our website. I take more live classes on our website also. We have a new mock test for you to practice, quizzes and questions, and you have doubts, and now the exam has been postponed. The CBSE class 10 exam has been postponed to June. So guys, we have special discounts going on, and I'm super excited to let you know that we have launched these new courses, the combo pack for CBSE class 8 physics, chemistry and maths, and also physics, chemistry and maths for ICSE class 10. These have just been launched. So please guys, if you want to sign up, do sign up for these courses. The links are given below. Or if you have friends, siblings, cousins who are studying in these classes, do let them know to check our website manochaacademy.com, because we have these full courses where we have interactive videos. I take more live classes, like I take live classes on this YouTube channel. I have more live classes there as well. We have mock tests, quizzes, questions, and ask doubts. And these are all full courses. Okay. I know some of you are in a different board, but usually, the CBSE pattern, the topics are pretty much the same. So do check out, because when you click on the course outline, the chapters are outlined there. So do take a look, and you can see if the courses are useful for you. And we've also given great discounts so that all of you can take these courses, and great to see more than 700 likes. Awesome, guys. Thanks a lot. I'm super happy to see that we have more than 700 likes in today's class. I really enjoyed the class. Hope you guys enjoyed it too. And this is Sandeep Manocha signing off. So please make sure before you guys sign out, hit the subscribe button and hit the notification bell so that you don't miss our videos or live classes, because I keep taking, live classes here as well, and we keep uploading sample videos here. And if you like our videos, you have more videos on our website as well. And thanks a lot for your love and support, and really a big thanks from the entire Manocha Academy team, because we are going to be soon a family of 4 lakh subscribers, and this is all due to your love and support. So thanks a lot, guys, and take care. Keep the momentum going. Keep studying. I know you have to work hard this time, but just remember that once the exams are over, you can relax. So please keep studying. And I put some videos on how to study and how to prepare for exams. So just search for that, how to prepare for board exams or how to study before the exam, Manocha Academy. You can search that on YouTube, and do check it out. You want to, for trigonometry chapter, you can search, I think I already have on trigonometry. You can search trigonometry, Manocha Academy. I think it's already uploaded on YouTube. So please take a look. And there are some more trigonometry videos also in our website. So take a look at the courses. All right, guys, take care. Have a great day. All the best. And please subscribe to our channel and do share our website with your friends. And a really big thanks for all your love and support. All right, this is Sandeep Manocha signing off. See you in the next class, and all the best with your studies. All right, guys, take care. Bye-bye.